All right. Well, hopefully you are progressing through the summer and you're enjoying your time away from school, but hopefully you're managing your math problems and just tackling, you know, 20 to 30 problems a week just to keep it up fresh in your mind. We're going to stick with the geometry components and 8.3. Eighth grade material, chapter 3, talks about angles and triangles. It says find the measure of the numbered angles. Now, we can only use this because of this little sign here. Those are very, very special signs. That means that these lines are parallel to each other. And this line cutting through the parallel lines would make this the transversal. So since it's the transversal, it creates very interesting angles. And we have 4 angles at each of the intersections. And we create vertical angles, we create supplemental angles, we create corresponding angles, and then we create alternate interior angles, and we actually create something that's not always taught in 7th grade is alternate exterior angles. So angle 1, well, angle 1 we know is going to be 76 degrees. And why is it 76 degrees? Because they are vertical. It's vertical to angle 76, well, not the 70-degree angle. So it's vertical to, that doesn't have an angle name, but it's vertical to 76 degrees. Angle 2, well, angle 2 is going to be 180 minus 76 because these are supplementary angles. So we're going to subtract and we get 104. So angle 2 is 104 degrees. And why? Because it's supplementary to 76 degrees. Okay. Angle 3, well, we can say that it's either supplementary to 76 or it's vertical to angle 2. So that is also going to be 104 degrees because 2 and 3 are going to be equal. And angle 5 we can say is 76 because it's alternate interior angle. And it alternates on the transversal, and it's interior to the 2 parallel lines. Angle 6, well, angle 6 is going to be 104 because it is corresponding. It corresponds. This is top right. This is top right. So angle 6 and 2 are congruent because they corresponds with angle 2. And angle 7 is also going to be 104 because they are vertical. It's vertical to angle 6. It is corresponding to angle 3, and it's alternate exterior, because it's on the outside, alternate exterior to angle 2. And I think that those were only, oh, no, angle 8. So angle 8 is going to be equal to angle 5 because they're vertical. It's complementary to 6. It's, supplementary to 6, supplementary to 7. It is corresponding with 76, and it is alternate exterior with 1. All right? All of those are important that we need to know. Find the value. Well, the sum of the angles in a triangle is going to equal 180 degrees. So we're going to add each of the angles together, and it should equal 180 degrees. Let's add these up first. We get 146 equals 180 minus the 146, giving us 34 degrees. So angle X should be 34 degrees. That should be an easy one for you to understand. This is good. So there is a relationship. I think we talked about this already, but this is going to be supplementary to this, right? X and this mystery angle are going to be supplementary. And we know that the sum of these angles are going to equal 180 degrees. The sum of these two are going to be 180 also. So this value is actually equal to the sum of the two other angles. So x is really going to equal 124 degrees. So we would add those together and then subtract from 180 to get this, and we would have that same idea. So instead of adding and doing all the work, we should know that this exterior angle is going to be equal to the sum of the other two angles. Really important idea. A polygon has 5 sides. The interior measures are 98, 119, 108, 118, and x. Find the value of x. So since we have a polygon, it's a 5-sided figure, and I think the formula, if I remember correctly, is 180 times n minus n minus 1, right? No, not n minus 1. Well, no, n being the sides. I'm just trying to think of it logically. Well, if it's 3, so n minus 2? Yeah, n minus 2. Because if it's a 3-sided figure, which we know, so 3 minus 2 is 1, and that would be it. Yeah, so 4-sided would be 360, and 4 minus 2. Yeah, so this is your formula for the number of angles, the sum of the angles in a sided figure. N is the number of sides. So we do 180 times the quantity 5 minus 2, 180 times 3, 0, 4, 540. So the sum of all the angles of a polygon with 5 sides is going to be 540 degrees. So we're going to add up 98 plus 119 plus 108 plus 118 plus x will equal 540 degrees. Let's add all those together and see what we get. So 98 plus 119 plus 108 plus 118 adds up to 443, plus the missing angle should all add up to 540. Let's subtract this, and you get x equals, that's going to be, 97? 97 minus 540 gives you 97 degrees. So angle that is missing, x, is going to be 97 degrees. Are the triangles similar? Well, we know that the sum of them should equal 180, so 95 plus 32 plus x should equal 180. So that gives us 127 plus x equals 180. Minus the 127 minus the 127. X gives us 53. So this angle is equal to 53 degrees. And 95 plus 53 plus this would give us 32 degrees. And yes, they are similar. They are, because they have the same angles. They are similar. Okay, that's a nice, good one there. Describe the relationship between angle 1 and 8. 1 and 8 are exterior, alternate exterior angles. And they're congruent, and that makes them congruent. Let's see what they, we've got choices, sorry. We got choices, alternate exterior. Yep, right there. All right, that's nice. Okay. I don't think it asks for, find the sum of the interior angle measures of a regular polygon with 13 sides. Hiya. Regular means they're all going to be the same. So we're going to use the 180 times the quantity n minus 2. We'll do 180, 13 minus 2, because it's a 13-sided figure. Gives us 9, correct? And, not 9, that would be 11. Mr. Mac almost made a mistake. 11 is easy to multiply 180. 1 goes out there, 0 goes out there. 1 plus 8 is 9. 8 plus 0 is 8. So that equals 1,980. Now we're going to divide it by 13. So 1980 divided by 13 gives us 152.3 degrees. So each angle, find the sum of the interior. So this is each angle. Each angle, I didn't read, each angle is that measure, and then the total sum is going to be 1,980. It says find the sum, so that's going to be that one. But because it's regular, we know that it's going to be all equal angles. So I was reading too much. Is there enough information to determine whether ABC and ADE are similar? Yes, there is. We have, I think we have angle, side, angle, 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 angle. No. We have angle. What are we going to do? We have, I know that this angle is going to be the same, right? This is the same. So angle A is going to be the same in each of those. We know that B and D are also the same angle. So we know that that's congruent. We know that this is congruent with this. And that would end up making these congruent also, because you would be adding the same number and subtracting from 180. So yes, we have enough. Angle, angle, angle is our reason. Number 9, the ratio of the interior angles of a triangle is 1 to 1 to 4. What are the angle measures? Well, you have x plus 4x should equal 180 degrees. So that makes 6x equals 180 degrees. Divide by 6. X gives us 30. So our angles are going to be 30, 30, and then 120. And those should equal up to 180 degrees, which they do. And 30, 30, 120. Least to greatest. Tell whether the triangles are similar. Tell whether the angles are similar. 180, okay. Well, do I know? I don't necessarily know that these are necessarily congruent. That can be 118, but I got it. Sorry. We're finding out what this measure is. Okay, got it. So we're able, because this is 59, this is 90 degrees, we can figure out that this is going to be 31 degrees. That equals 90, right? 90 is 180. Good. Now this is 118. This is 31. This also has to equal 180. So we got 118 plus 31 gives us 149. Subtract 180 and 149. You get 31. So this is 31 degrees. This is 90. That makes this 59 degrees. So yes, they are similar. All right. Took me a second there to see that one. That was a good one. Number 11. So number 11 says a street light that is 9 feet tall here's my street light. And that street light is 9 feet tall. Cast a shadow 2 feet long. Okay, so we've got a shadow that is 2 feet long. Okay, that's the shadow. A nearby flagpole casts a shadow. So that shadow is, let's move that flagpole. So that shadow is going to be is 11 feet long, and it says what is the height of the flagpole. So we want to know what that flagpole height is. So we're going to create a fraction, a 9 over 2, because this is the actual and this is the shadow. 9 over 2, actual to shadow is, okay, so now we're not going to multiply by, we could, but it's just easier to do 2 times x equals 9 times 11. 2x equals 99. Divide by 2. And we get x equals 99 halves. Or we can divide it, which gives us 49.5 feet is our distance, is the height of the flagpole. 49.5 feet. An architect, our last one problem, an architect designs 2 similar triangular patios. The first patio has angle measures x minus 5, y plus 20, and 50. The second patio has measures x minus 15, 60, and 70. Find the values of x and y. Architects 2 similar. Okay, so they're similar. So we have this. So this is going to be x minus 5. And what are we going to do there? Well, I don't know if we have to draw a figure here, but we can add them up. We have x minus 5 plus y plus 20 plus 50 equals 180. And we also have x minus 15 plus 60 plus 70 also equals 180 degrees. So x, that's 45, plus 70 equals 180. That's x equal, whoa, not equals, that's plus 115 equals 180 minus the 115. Gives you x equals, that's going to be 65 degrees. So we can substitute that in there. 65 for x, minus 5 plus y, plus 20 plus 50 equals 180. So x equals, well, 65 degrees. We know that one. And that'll make 60 plus y plus 70 equals 180. Y equals, not y equals, why do I keep saying equals? Sorry. Plus 130 equals 180 minus the 130 gives us y equals 50 degrees. So the y value is 50 degrees. Good. All right, that didn't get too complicated. That seems relatively easy. And those are the answers which are posted. So good luck. That was nice and quick. 12 problems.